So today and probably tomorrow we'll be doing characteristics of piecewise functions. This was another thing you were supposed to do in Math 3, and I'm assuming you did not. I put the copies over there. I'm assuming we did not, but maybe we at least plugged numbers into piecewise functions. Did we do that in Math 3?
Yeah.
No? Yes? Yes? Plug numbers into piecewise functions?
I remember doing
Yeah?
it. I don't
Okay.
remember doing it.
Okay, so we have this piecewise function, the first one. It has 3 different pieces. So the first piece, and actually this would be great if you had colors for, so feel free to grab some markers or different colored pens or highlighters, colored pencils, something like that. Different colors would actually be really helpful here. I'm going to have 3 colors for the first problem and 2 colors for the second problem. That's going to be helpful. So it says to use the cubic graph if x is less than or equal to -2. So I'm going to make this one blue. There's my cubic graph. And then it says to use the square root graph if x is between -2 and 3. So there's my square root graph. And then it says to use the constant, just use the plain number if x is greater than or equal to 3. All right, so -6 is that less than -2, between -2 and 3, or greater than 3? -6. It's less than -2. So I'm going to be using, you could use the first graph if you could see that point on the graph, but we can't. And so we're going to have to use the equation. So I'm going to go ahead and plug it in there. So I've got -6 plus 3 to the 3rd power. And you can plug it in your head. You can do mental math for that, or you can plug it in to the calculator. Either way is fine. So -6 plus 3 to the 3rd power would be what? Not quite to the 3rd power. -27. Perfect. -27. Okay. If we were to plug in -2, which piece would we plug in -2 for? The top one. The top one is where it has an equal to, although technically it doesn't really matter because the first piece and the second piece actually come together. So that's where the circle would be filled in. That's where it would be a hole, but the 2 pieces of the graph do come together in that one spot. And you can see what the y coordinate would be from the graph. What would it be? It'd be 1, yeah. -2 plus 3 is 1. 1 to the 3rd is 1. But you can also see it just from the graph. The y coordinate is 1, so the output should be 1. All right. Which piece would you plug in 0 for? The second one, 0 is between -2 and 3. So if we plug 0 in, we get the square root of 0 plus 3, which is square root of 3, whatever the square root of 3 is. It's 1.7, I think. Square root 3, 1.732. Okay, and then if we wanted to plug in 3 exactly, what would we get if we plug in 3 exactly? Yeah, it'd be the last one. And so with plugging in 3 exactly, there's no place to put an x. It just means that whatever you plug in, the answer is going to be -2. No place to plug it in. If you plug in 3 exactly, you just get an output of -2. If you plug in 4, you get an output of -2. Plug in 5, you get an output of -2. So there's no place to put the x value. You just get the output of -2 regardless of the number that you plug in to that particular piece of the function. What would happen if you plugged in 100? You would get -2. We're plugging that one into the last piece as well. Okay. It is not on the graph. It's too big to be on our coordinate axis, but it would be in the last piece because it's bigger than 3. Okay. Domain. If we look at the graph from left to right, I see left is an arrow. This graph goes forever to the left. It goes forever to the right. I'm a bit concerned about the x value of 3. Is the x value of 3 there, or is it missing? It's there. It's missing right here, but it shows up right there. So the x value of 3 is not a value that is skipped. So this domain is all the way to the left, all the way to the right. No missed values. Every single value gets used. Okay, the range is going to be a little bit trickier. The first part of the range is pretty easy. If we think from down to up, how far down does this graph go? It goes down forever, right? Everyone see the arrow going down? It goes down forever. Now, when we look at how far up the graph goes, you can see that there's a point where it stops. And the point where it stops, is that a nice whole number? No, it is not. Okay, so for the range, this is a y-coordinate, and I want to find the y-coordinate where it stops. And to find the y-coordinate where it stops, I need to figure out what piece I have to plug a value in for, and I have to figure out what value I should plug in. So which piece am I going to use to find the upper part of the range? The first piece, the second piece, or the third piece? The second piece has the very highest point of the graph. And then what x value should I plug in to find it? I'm going to plug in an x coordinate of 3. Okay? Now, when I get the y value that corresponds to that x coordinate of 3, is that y value going to have a parenthesis or a bracket? Wait. Is it going to have a parenthesis or a bracket? Look at this. It's going to be a parenthesis, not a bracket, because look at this. Is this point included or not? It is not included. It's a hole. Even if it stops. It's where the graph stops, but this point isn't really there. It's not filled in. Everyone see that? This point is not included on the graph. It says where x is 3, that point is not included on the graph. Everyone see that? This point down here is included. This point up here is not included. So when we find the y value that goes with that point, we are not going to include that as one of our answers. We're going to write it down because the graph goes right up there. But when we actually consider what decimal values we could use as part of the range, we're going to say all the decimal values that are right underneath that decimal. So we're going to find it, but we're going to put a parenthesis right there. So I'm going to take the middle function. I'm going to plug in an x coordinate of 3. And I'm going to see what my y-coordinate is. So if I plug in an x-coordinate of 3, then I've got the square root of 3 plus 3, which is the square root of 6. So 2.449. If we wanted to be more exact, we could put square root 6 just to be more exact. So you can do 2.449, or you could put square root 6. Either one of those answers is good. And we're going to do a parenthesis because we cannot equal that point. We can get right up to that point. We could do 2.448, 2.4489, anything that's right underneath 2.449. Does that make sense? We can get right up to it, but we can't have that point exactly. Okay, so we've got from down to up. Increasing intervals. So if I've got my stick figure, what is my stick figure doing right here if he's walking? Uphill or downhill? Uphill. This is increasing. Okay, my stick figure's walking. He's walking. He levels out for a little bit, and then what's he doing right here? This is increasing. Okay, what's he doing here? Increasing. Okay, and then here he falls into the hole and dies. This is a very, very sad death for that stick figure. And what was the X value right here? 3? Okay, and what is the X value right here? Negative infinity. Okay, so that stick figure is done. Then there is some sort of miraculous experience for the stick figure where he has gone into the hole and he dies, and then he miraculously rises from the grave. I'm not going to say he's Jesus, but maybe he is. And then he starts off again. He's still at an X value of 3. And this time, he's not increasing or decreasing. He's not walking uphill or downhill. He's walking on a flat surface, and we call that constant. Not uphill, not downhill, just constant. And he's doing it from 3 all the way to a right arrow, which is what number? Infinity. Okay. So what type of interval do we not have anything for? Decreasing. So over here we're going to say none. All right. Now for increasing, he goes uphill, 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 uphill. And so what numbers was he increasing in between? Negative infinity to 3. Okay. And at negative infinity, that's an infinity. It always gets a parenthesis. Over here at 3, when he was falling through the hole and dying, was he actively walking uphill? No, because he was falling through the hole and dying. Okay. For the constant interval, from 3 to infinity over here, that's the answer for constant interval, so I'll go ahead and write that. For the parenthesis, for the infinity, we're always going to get a parenthesis. Right here, we're going to drop him down, and this circle right here is filled in, which means you can include it as part of the answer. So when I drop him down right there, it's part of his walking on a flat surface. He's constantly walking. Think of it as like you're at the airport, and the minute you step on that little I was going to call it a treadmill, but the minute you stop on one of those things, it makes you go faster. You know what I'm talking about? When you're walking on the ground and then you're ooh, I got to walk a little faster than the people next to me so I can get to my my gate faster than everybody else. So we're going to put a little bracket here. Now, if you want to always use parentheses for increasing and decreasing, that's fine. They will actually never mark you wrong for that, even if you were to do this in a calculus class or something. Increasing and decreasing is one where if you use parentheses, they'll just count it as correct. So, but if you wanted to put a bracket there, it would be correct to put a bracket. Okay, continuous. If I trace this with my finger, can I trace the whole thing without picking up my finger? Nope, I got to pick up my finger to jump over here. So this graph is not continuous. It is not continuous. Okay, end behavior, I'm going to look at my left arrow. As x goes to negative infinity, that's me looking at my left arrow. And when I look at my left arrow, what is the left arrow doing? Which direction is it pointing? It's pointing down to negative infinity. My left arrow is pointing down to negative infinity. All right, and then as I look at my right arrow, this one's interesting. It's not pointing up, it's not pointing down. What is it pointing at? -2. Y is pointing at -2. Didn't point up, didn't point down, pointed at -2. Okay, are there any of those answers that I could re-explain? Anything that doesn't make sense? So this one, the arrow's not pointing up, it's not pointing down, it stays in the middle. And the middle that it stays at is -2, a y value of -2. We good? Okay, let's try the next one. All right, so our first piece is the parabola that is to the left of -3. To the left of -3, so we've got this piece right here. To the left of -3. And then we have the linear piece to the right of -3. Okay, so if we're plugging in -6, is that to the left of -3 or to the right of -3? To the left of -3. So we're going to do -6 plus 4 squared. What is -6 plus 4 squared? 4. And you can see that on the graph. -6 has an output of 4. So it equals 4. Okay. If we look at -3 exactly, which function do we get to plug it into? The first one or the second one? The second one, that's where it says you can equal -3. Okay. So we're going to subtract, we're going to do the opposite sign of -3. -3. And what happens with the minus? Positive. So we've got 3 minus 3 is 0. And you can see that -3 has an output of 0. Okay. Which one are we going to plug 0 into? First one or second one? Second one. 0 is bigger than a -3. So opposite sign of 0 minus 3 is -3. And you can see that 0 has an output of -3 there. Okay. And then which one do you plug 10 into? The second one. Okay. So we have the opposite sign of 10 minus 3. -13. Okay. All right, so domain, we're going to go from left to right. So all the way to the left is an arrow. All the way to the right is an arrow. So I'm thinking it's probably -infinity to +infinity, but I just want to check. It looks like there might be an issue at -3. So is -3 being skipped? Or is -3 included? Included. So it is skipped right there, but it is included right here. So I thought maybe it was an issue, but it turned out not to be an issue after all. So the domain is left forever to right forever. -3 made me think for a moment, but it ended up being okay. Left forever to right forever. Does that make sense? Okay. The range. What do you guys see about the range? Same thing. We got down forever. We've got up forever. The range value, y equals 1, is making me pause for a second, but y equals 1 is right here. So I'm not really worried about a y value of 1 because I can see that it actually shows up on the graph in a different spot. So down forever to up forever. My range is also all real numbers. Okay, I'm going to go ahead and put my stick figure on the graph for increasing and decreasing. So I've got my stick figure right here. And what is he doing first? Decreasing. He goes downhill. And he goes downhill all the way to what value? Yeah, -4. Okay. And then once he decreases to -4, what does he do? He increases for how long? Just one little space. He increases up to this value of -3, and then he goes into the hole and he disappears. And he disappears for all eternity. That stick figure did not resurrect like the other one. So sorry, guys. And then a wee little stick figure is born. He's a wee little baby. And this wee little baby goes down the slide. And so which direction is this? What do we call it? Decreasing. And the wee little baby went down the slide starting at what value? -3. And then what value do we have down here at this arrow? Negative infinity or positive infinity? Positive infinity. So be careful to think of your arrows as x values instead of y values. So we're thinking of the arrow in terms of left and right instead of in terms of up and down. So this is a right arrow, which makes it a positive infinity. What number should we put for this arrow? Negative infinity. Okay, so what should I put right here? Increasing interval. We have one increasing interval. -4, -3, and then someone other than Carly tell me brackets or parentheses for the -4 and -3. Parentheses. Somebody tell me why Miriam said that. Why does it make sense to put parentheses? So here's -4. Why does it make sense to put a parenthesis on -4? Yeah, you're not increasing, you're not decreasing, you're kind of in a neutral space in between. Okay, why does it make sense to put a parenthesis at the -3? Yeah, it's a hole, it's not actually on the graph. That point isn't really there. Okay, so parenthesis on both of those. Okay, decreasing, we're gonna have two answers. We always do the left one first. So what is the first decreasing answer? Okay, so negative infinity, -4, parenthesis or bracket on the -4. Parenthesis. So that -4 is in between, increasing and decreasing. It's kind of in a neutral space. Okay, and then what should we put for this other decreasing answer? -3 infinity. Infinity is always a parenthesis. And then the -3, should that be a parenthesis or a bracket? Bracket. And if you put a parenthesis for everything, that would be fine as well. Now, anytime we have two answers for the same type of interval, increasing as two intervals or decreasing as two intervals or something like that, or if the domain had two intervals or if the range had two intervals, you're supposed to put a U in between. I will not mark you down if you don't. What the U means is union. It means that you have to have both answers at the same time to be right. You can't have one or the other. You have to have both to be true. They have to both be there. If one is missing, then it's wrong. All right. Is there a maximum, meaning is there a mountaintop anywhere in the picture? Do you see a mountaintop anywhere in the picture? Okay, so we're going to say none. Minimum, meaning valley. Is there a valley anywhere in the picture? Yes. What is the valley? -4, 0. I'm going to do the x coordinate and the y coordinate. The minimum is a valley in the picture. Okay. X-intercepts. Are there any x-intercepts in the picture? What are they? -4 is an x-intercept. -3 is an x-intercept. Now, one thing that might come up in some of the drawings, I can't remember specifically, but if you end up having a hole specifically where an intercept is, do not include it as an intercept because it's not actually a point. So that's not happening here, but it could happen on one of the graphs that we have. I don't remember if it happens or not, but it could happen. So if something is a hole, that point is not there and it is not an answer. Okay? So if that point ends up being on an x-intercept or on a y-intercept, you would not write it down because that point does not exist there. We also have a y-intercept. What is the y-intercept? -3. So we also have 0, -3. Okay? End behavior for this one. So what is the left arrow doing? It is going up. The left arrow is going up. So left arrow goes up. Okay, what does the right arrow do? The right arrow goes down. So left arrow goes up, right arrow goes down. Okay, how are your brains feeling about finding the different characteristics? Yeah, positive is the x-coordinate. So it's to the right, that's the positive piece. And then the negative piece is the fact that it goes down. So whenever you look at an arrow, there's always two types of infinities that can be represented by that arrow. One for the x-coordinate, one for the y-coordinate. Yeah. Okay.